Hello everybody, my name is Josh. I was a computer science examiner for multiple exam boards, head of computer science in UK based schools, and now I run a tutoring business. What I've been doing with these series of lessons is I've been trying to do these kind of longer style questions which seem to be really helping people out. So this is what I've been trying to do, listening to you guys. And I'm going to be tying up the data structures unit because I did miss out a couple of them which were not relevant to every single exam board. So I'll try and chop this video up so it's relevant to the specific exam board, but just in case you're on the wrong one, Cambridge International, you only need to do linked lists. AQA and OCR, you need to do linked lists, circular queues, priority queues, and then AQA just has to do the vector stuff. So as I said, just go on to the specific video for the exam board, but I've tried to go through in the same format and going through all that kind of making it easier for you to essentially revise it. So we'll start off with linked lists. Now, one of the big things, I was actually, someone was asking me about this, and I thought I better include this. So the difference between static and dynamic, and mutable and immutable, because they kind of sound like the same thing, and I can understand why people sort of get a little bit confused by it. So let's have a chat about those. So dynamic data structures essentially means that the size can grow during runtime. Okay, and a static data structure, we have to set the size. It means that we can add things in during runtime, but let's say that the limit that we'd put on it was 10. We can go from 0 to 10, but we cannot then go further than that. Now, the difference with mutable and immutable. So mutable means that the values can change during runtime, and immutable means that they cannot change during runtime. So if you kind of think about like a tuple, we cannot edit it at all. So it is an immutable data structure. So during runtime, there isn't any, so you know with what I was saying with a static data structure, going from where we can change the size of it, but there is a limit to how much we can change it. If it's immutable, if we've already put 5 values in there, we cannot change that during runtime. We have to stop the program and then physically change it. So that's the difference between the two of them, is that static is it just can't grow past a certain point. Immutable means it's fixed in size until we stop the program and then maybe edit the data structure that we're referring to. So I just thought it'd be a really good idea to just talk about that and just make sure that you understand that. Anyway, there's a couple of things where they talk about make sure that you're able to discuss the advantages and of each of a dynamic and static data structure. So I thought I'd go through that. So obviously with dynamic data structures, with such as lists, you don't have to preset the amount. So if you maybe didn't plan for something to go over a particular amount and you need to add that in there, it doesn't matter. Your program can compensate for that because a list can grow infinitely as long as the memory allows it. Now, static data structures, they save it. I guess probably the main advantages of this is that it saves memory. If you've got limited memory capabilities, it's actually a really good idea to be able to kind of have this more efficient model, and it means that essentially your hardware can cope with some of the if you've got limited hardware, that it can cope with the different kind of data structures in there. It also forces you to plan how your code is going to work, and then you have to have a full understanding of how much is going to be working, how much data is going to be needed in each different data structure. So those are the kind of main advantages and disadvantages in there. Now, going on to linked lists then. So let's talk about what a linked list is. It's an abstract dynamic data type or data structure that uses nodes. These nodes are made up of data and the pointers. So we'll be having a little look at an example in a second of what that actually means. They're used for lots of different things. An example that I just put on there was tracking web pages visited. So it's got all of those. I was scouring through all of the different exam papers and that I was having a quick look at, and I noticed this one, and I thought it'd be really good to talk about how to add data to a linked list. It seems to be that if it's applicable to add data or remove data from particular data structures, that you need to really understand fully how this actually works. And anyway, let's have a little look at this one. So you've got a linked list, which is these cities here. And what's going to happen is Birmingham's going to be removed. So that's going to how we're going to remove data. And we're going to put York in there. And that's going to go into this particular linked list. So let's have a look at, I'll talk about it generically, but I'll also relate it to the question so that you can see the difference between the two of them, because they may just generically ask you to talk about a linked list, but the more likelihood is that they're going to ask you to apply that to a question. So first mark is node is created for a new value, which in this case is going to be York. So you get a mark just for saying that. The pointer of the node before, it changes to point to the new value. So the one which is before York is going to be, so as you can see, it goes in this order. So London, Oxford, Manchester, and then York. So Manchester is then going to point to York and is no longer going to be null. The new node either points to another node in the sequence. So say if York was in the middle and we needed it to then point to, I don't know, Oxford, we'd change the pointer in York to fit that. But in this case, York is at the end of the linked list. So we need it to point to what's called null. Okay? And that's where we go. So it's at the end, so it's just going to point to null. There's 3 marks there, even though it's a 2-mark question, but that's the whole process. To remove data from a linked list, essentially what you're going to do is the node before the node to be taken out changes its pointer to the value after. So Oxford is no longer going to point to going to point to Birmingham, is going to point to Manchester, because that's the next thing in the list. And that's how we take that out of the linked list. And I would just get a flashcard down for each of these, because it's a set sequence. It doesn't matter what they're asking about the linked list. That's just got what they're, the process and how it works. Just a little one, I did include this on the last one, but I just remember that there was a follow-on question where it was asking you to do advantages and disadvantages of linked list and hash tables. So just a quick reminder on this one, because just talking about the kind of questions that could come up. The idea of hash tables is that it does things instantly, and it generates you a value, and you can search and insert values instantly. Linked lists, you need to go through everything when you're searching, so you have to go through everything. So the process is a lot slower. So that's the kind of main advantages and disadvantages of hash tables and disadvantages of linked lists. So that's the only things which are going to be relevant for Cambridge International. And now we're going to have a quick look at circular queues, which says OCR there, but it's also AQA actually as well. So we need to have a look at this one, make sure that we understand it. If they ask you to define it, abstract dynamic data structure, which is a FIFO data structure, first in, first out, and uses pointers to overcome limitations of linear queues. We're going to look at why it works a little bit differently. Queues for jobs to be processed by the CPU. So a circular queue works in that way. And what that means is it gives each item a time slice, so it's working on a particular activity. Once that time is up, if it's not finished, then it goes to the back of the queue, and then it goes through, and then it will get round to it again, and it works in a circular queue. So how do we add to a queue? Now, what I always try and do is make it as efficient as possible for you when you're getting this information down. A lot of this, you can use a lot of the same wording. Oh, it's not the same as a queue, but the way I kind of think about it in your revision is if I can give you less to remember, you're going to get better marks because there's less that you've got to remember, so you're more likely to remember it. You still use NQ and DQ. We're actually going to have a little look at how it's slightly different, and I'm going to show you the code and why it's different. But as I said, I'm just trying to get you to learn stuff that's going to be so that it's going to make it easier for you to get the top grades. So if you can use the same wording for literally the same for the same point, use it. You're going to get the marks for it. So you've got to check if the queue is full. That's same as the one before. If not, you're going to add one to the rear pointer. And I'm going to, as I said, I'm going to show you how it's slightly different because you have to use mod. But anyway, I'll show you in a sec. And then remove data. Again, exactly the same. DQ. Check if the data is empty. Return the value pointed by the front pointer. And then increase the front pointer by index 1. Now, what you're going to see here is this is the pseudocode for circular queues, and you can see that if it's not full, we're going to go with these ones, and we're actually going to mod it with the max value so that it can go round from, say, I'll show you in a second, but it means that it can loop round then. I'll show, if you're a bit unsure of that, I'll show you exactly what I mean there. So yeah, mod there as well. I don't know why they've used the percentage sign there, but anyway, doesn't matter. But it's the, so they just mod the values, and that means that we can loop back round. So again, flashcard for these, because they sometimes do just say, write the code for adding an item or removing an item. So pop that one down. Now, I wanted to show you a little visual of how a circular queue actually works. So with the idea of a circular queue, and the limitations of a linear queue is that it can actually be quite challenging to search for values and remove values in the middle. And what the circular queue is, it overcomes that, because what happens is the front can be zero. The back, the rear can be 0, and the front can be 2. And it's this idea that it loops round, but creating that situation is a little bit of an interesting, is a little bit more difficult to do that. And the way that it does it is mod. But yeah, the front's here, the back's here. This York must have been dequeued earlier on. So it goes in this order here. And then if we needed to, add another item, then this would be removed. But I just wanted you to see that visual representation of it, where the front's actually here and then the back's here, and it's, even though it goes 2, 3, 4, 0, how does it actually create that? How does it know to go from 4 to 0? And that's the question that you need to be asking yourself, is like, how does it go from 4 to 0? And it could potentially ask you to explain that, which is what I'm going to show you how it does. Okay, so let's say that we want to try and generate the next value after 4 to be 0. So the algorithm of how it works is it adds 1 to it, and if we know that we've only got 5 items in our circular queue, what we do is we mod it with 5. So 5 gets modded with 5, which gives us a remainder of 0. And that's how it loops back round, even though 4 obviously doesn't sequentially come after 0, it can still loop back round. And that process is how a circular queue can work, almost, where it gets its name from, in a circle. Main advantages of circular queues: it overcomes the limitations with insertion and deletion of middle values in linear queues. It's quite difficult to do that in linear queues, so that's one of the main advantages of it. It is more complex to implement, is probably the main disadvantage of it. So I put a little disadvantage there for you as well, because it sometimes does ask for that. Anyway, priority queues, still OCR and AQA. Priority queue. Abstract dynamic data structure allows certain values to jump the queue, so it's no longer a FIFO data structure, so don't use that. And exit the queue even though they entered it after the other values, I should say. So other values. So there we go. Examples: airport boarding. Yeah, if you first class, you get to go first. So that is a priority, even though there might be some other people queuing up. First class people get to go on first. A&E is another one. So if you have a more pressing condition in accident and emergency, you then get to go and see the doctor before, because it might be time critical whether you're going to be okay or not, rather than someone that maybe has just, like, I don't know, done something not so bad. Priority queues. I was having a look around on all of the different exam papers. That the only thing that I could find really was it gave you a load of different values, and it was just trying to say to you, like, what can you put this in a priority queue? So it's saying like A, B, and C are, so it goes A being the highest priority, C being the lowest priority, B being the middle one. Like, how does this go into a priority queue? And that, in this case, it's the numbers don't have any bearing on it. It's literally just whether it's A, B, or C, and then it's the order in which they're put in there. So B goes at the front if we're organising it. Then that one then goes at the would go behind it. 142A jumps the queue and goes to the front. 25C goes right to the back, and then 87B goes in between 92 and 64. So that gives us all of those values there, and then it's just about essentially they'll give you just a list of items, and you just have to be able to put them in the correct position, and that's that based on the priority that they've assigned to each of them. If it says 142A leaves, so that leaves, and now 92B is in the front of the queue. 75B, because the numbers don't have any bearing, that would just go in between the 87B and the 64C. And they may ask you to just describe that process. They may ask you to just say like what are the general steps in this. That would be just describing that process is what I'd do.